Okay, so in this video I'm going to teach you, or at least talk to you a little bit about how I think that you should structure your JavaScript in order to make it safer, and basically how to create safe JavaScript overall. Now, I will make you an argument, and I will make this argument knowing full well that I may be wrong and you may not agree with me, but my argument is that the only thing that in theory you are not able to control by yourself in any given system is what's coming into the system and what's going out, what's basically leaving the system. You basically, as soon as something is outside of your own code, you don't have any control of it. You can know what's coming in, you can check what's coming in, and you can send something outside of your system. So in this case of a server, you know that best practice is that you always make sure that you're validating everything that's coming into the server, because you can't trust any information that's coming outside of the system. That's how hackers get to you. That's how all these types of malicious users corrupt your system, and even users who are not corrupt may actually break your system because they might be misusing your application, or maybe your client code is not structured correctly. And I want to take that idea and I want to apply it to JavaScript as well. And I argue that this is not happening in most applications, and I'll show you a few examples of what I'm talking about. So here we have a very simple web page. It's just a static page with a single script, and we're running a very simple server, and all our application is doing is that it's creating an h1 element, and it's basically putting up my name there. So let's look at the network here. So what's happening is that we make a single AJAX call to a user endpoint, and it's going to return a user that has the name of Fredrik Christensen. That's our entire application. Now let's look at the script. So this script, it's fairly simple. You have an async function basically that is going to do a fetch call to /user. We'll talk about this in just a moment. It parses the response as a JSON object. We have some data basically, and then we create an h1 element, and then finally we do data.user.name, and we set the h1's inner HTML to that, and then we append the h1. Easy peasy. Now, what's the issue with this? Well, the first issue is that we are assuming the shape of our data in this scenario. Basically, if this shape, the data.user.name, if this shape changes, odds are that we're going to break our code. So let's just assume, just for in theory, that our endpoint changed, or the data that we are now receiving from the server has changed somehow. It could be an error, it could be a mistake on the server side, whatever. And now we load it, basically we load the empty endpoint, and see what happened. On this endpoint, we're getting an empty object. And the issue here is that this completely broke our application. Because we assumed what the data was going to be in our application, we now have a very fragile system. Basically, the whole application broke just because we didn't do any type of checking. Now, this isn't the end of the world. Let's look at another example to see how we can kinda do this in a slightly nicer way. Let's refresh this. So name is missing. What's going on here? Okay, so we're hitting the empty endpoint. We're still getting that empty object. Something's not going as we planned. Let's look at it. So let's see here. So we're getting the empty object. We're parsing the response, creating the h1, and here's something different. So we're doing something called guarding. You may have seen this before. So we're checking that data is a truthy value. Then we're checking that data.user is a truthy value, and then we're checking that data.user.name is a truthy value, and if it is, then we return data.user.name, and if it's not, we simply return a default value. This is basically a slightly safer way. Like we're not we have a shape that we think is going to come over the wire. We're not sure, so we're guarding in order to check if that value is really there, and if it's not there, we'll simply return a default string. This is one of the most in my opinion, one of the more powerful techniques you can have, because to me it makes a lot of sense to, when you're displaying information to a user, if you break the code, the whole application kind of goes down. Like now at least the user has a way of seeing that something is not, like basically what is going wrong with the application. Name is missing. Okay, that's something that we can deal with. But if it's just a blank page, as we saw earlier, it becomes very tricky for you to communicate to the user that something is broken. And maybe that's what you want, but I like to have this. I like this approach. But let's go one further. Let's say that something is not broken anymore, and we simply have a version 2 of our endpoint. So something has now changed in the data structure on the server, and we're getting new information. Let's run this. What happened there? Well, let's look at it. So version 2, so now we have a new endpoint, we're getting some new cool features in our application, and all of a sudden, what's this? Well, if you think about it, in the first scenario, name was a string. But if you really break it down, a name is actually made up of at least two parts. You have, in general, a first name and a last name. And our developer colleagues on the server have realized this, and the specification for how we're storing names has now changed. So now instead of just having a flat string, we have an object. And if we look at our code, we're not actually checking what name is. We're simply assuming that name is a string. And, we're basically just checking if it's a truthy value. And since we know that JavaScript will say that something is truthy, as long as it's a string with something in it or an object, this is going to break now. So this isn't all that nice. So let's have a look at another example to go one further. So let's refresh. Name is missing. Cool. And we're still on endpoint version 2. So we're still getting the name as an object now. Let's look at this one. So we're grabbing the data, parsing it, making the H1, and here we're doing our guarding data, data.user, data user name, and then finally we're doing type of name equals string, and if the type of the name is a string, then we show the name. Otherwise we show this default message. This is, to me, a very sane way of dealing with this type of problem. However, I can tell you from experience that doing this type of validation for every single thing, it gets a lot of, especially if you have a lot of functions and maybe because this is a very easy toy example where you have a single property. Usually the case is that you have much more complicated data structures than what you're seeing here. So I'm going to show you the way that I believe you should approach solving this type of problem, and it is through using what I call an adapter, or rather a pattern that is called the adapter pattern. And basically what the idea is that you have something coming into your system that is not in what I like to call it. This is not the definition, but this is the way that I think about it. You basically have a data structure that's coming into your system. You have no idea what shape that data is, because remember, anything outside of our system we can't trust. So you get it in, and then you have a adapter in between your system and the external thing. And that adapter is responsible for transforming the thing that's coming into your system into something that your system can understand. So let's look at how that could look. So let's look at main 4. And now we have a slightly more complicated application. So we have a version 3 now. Our application has changed again. All those guys working on the server, they've made some changes. So now we have a user, and our user has still is the first and the last name as an object, and then they have a list of subscribers. And these subscribers have their own names, and inconsistencies. They're horrible, right? And you may think that I'm making this up, but I'm not. This is actually very common. It's very common that you may have inconsistencies in data, or that name is sometimes, it may be a string, but it could also be an object. Same thing goes for address. Address is also one of those where it could be an object, it could be a string, it could even be an array sometimes. Anywho, these inconsistencies are a problem for us as the developers of the client, because we need things to be in a certain shape, otherwise the whole page breaks, right? So here is my final version that we'll just walk through this very briefly. So there's a lot of code here. So let's just start at the stuff that we already know about. So we're getting the response, we're parsing the data, and this is where the magic happens. We have this user function that takes in the data and returns a user. This is my adapter. So the way that I think about structuring safe JavaScript is that whenever I'm getting something from outside my own code, I want to have a adapter in between my system and the thing that's coming in. This function is responsible for returning a trusted data structure that I now know, even if it's not getting the values, even if the data is wrongly formatted, even if it can't get the exact correct information, I can trust this data structure. That's why I'm safely going to do user.name, because I know that this is going to have a name property. I know it's going to be an object. I know it's going to have a name. This name may be an empty string, or it may be the name that came from the server, but I can trust it. And then we create an unordered list, and then I see user.subscribers, and I know that subscribers is going to either be a list of subscribers or it's going to be an empty array, but I can trust it. So I iterate over the subscribers, and in this scenario, I'm simply allocating the inner HTML with the subscriber because I know that the subscriber is going to be a text, like it's just going to be a string of some sort. Let's walk through the code. So here we have my user adapter. It takes in the data, it does guarding, data.user, grabbing the user of the data or trying to get the user, and then it gets the user's name, or tries to anyway, and then it gets the user's subscribers, or tries to. As we know, I can't be sure that any of this is actually there. I'm just guessing now. These things may or may not be there. And then I have a object that is going to be returned, and this is where the magic is. This object, I shape it in the way that I want my own code to work, because as we saw earlier, I assume that there's going to be a name property, and I assume that there's going to be a subscriber. But that's the beauty of it. I don't care what's coming into my system. All I care about is what my system needs in order to work. And then I use the adapter to try and shape what's coming into my system into the format that I need on my end of things. And what's powerful about this is that me and my colleagues may not have decided what the shape of the data is going to be when they start working, and I don't care, because the only time I have to change anything, let's say that I get it wrong, let's say that the shape that I think things are going to come into, maybe they're not in that shape. These assumptions happen all the time. But the beauty of this is that I only have to change my code in a single place now, because anything that happens after this line here is safe. Alright, so I have a getName function, then I have a function called getSubscribers that takes in the subscriber, and then I do a filtering. We're checking that, everything that's coming back from the subscribers function is actually an object, and then finally we do a mapping where we extract the name from the subscriber. So let's walk through this code here. So I take in something called subscriber. I don't know what it is, so I check, is it an array? Because if it is an array, then I'll just return it, because I expect that I need an array. That's what I want my subscribers to be in the shape of an array. And then I check, is it an object? Because it may be an object. I've seen this many times. Sometimes a list comes in the form of an object, sometimes it comes in the form of an array. It can vary. Usually, if you're in control of your server, you know this beforehand, but I like to add these checks anyway. So I extract the values from my subscribers in case it's an object, and that's going to return an array with all the stuff that's in the object, basically. And if it's none of that, I don't know what it is, because I'm really only looking for it. I can only handle it if it's an array or if it's an object. Then I just return an empty array, because I need it to be an array for my code to work. Then I have a getName function that simply takes in something that may be a name. I don't know what it is. First, I check if it is a string. If it's a string, then I simply return it, because I need the name in my code to be a string, as we saw earlier. But if it is an object, okay, then I'll try to. I don't have to do this, but I'll try to. I'll try to see if I can get the first and the last, or the first name and the last name from this object. And then I check those things. Like I'm checking if the first name is a string, and I'm checking if the last name is a string. If they are, I'll just put them together and return the full name. Otherwise, I'll simply return name is missing, because I don't, I have no idea what's going on, and I'll just show some default value instead. And if it's for some reason something completely different, I can't match it against any of these cases, I'll simply return a default string. And these two functions are fairly simple. They just check the type of the value. So hopefully this has been I hope I can sell you on the idea that what's beautiful about this is that I only have to check the shape of the data once, and that is where it's coming into my code. Everything that happens afterwards is completely safe, because I have created a secure data structure that is always going to have the shape that I need in order for my code to work.